All right. Today we're going to talk about graphing of linear inequalities. When we talk about the graphing today, it is different than the graphing that we have already done. The graphing that we did earlier was on a number line, and that was like a single variable inequality, where we had like x is less than 3 or x is greater than or equal to 8 or something like that. We just had an x or some other variable all by itself. Okay, now today what we're going to see is our slope-intercept form, or our standard form that we've been using for a couple days now, and we're going to graph it on a coordinate plane. So we're going to graph it on an xy axis. The first thing we're going to do, because the first couple of problems on your assignment are going to look like this, they're going to give us an ordered pair. And we want to know, is this ordered pair a solution to this inequality? So we have an inequality, and we're not necessarily going to graph it. We could graph it if we had to, but on this one we don't have to. This is my x, this is my y, and we're going to plug that ordered pair into the inequality, and we're going to determine if it is truly a solution or not. So 3 goes in for y. Now, here's where you got to really be careful. Signs make the difference, right? The opposite of -1 or minus a -1, however you want to read it, same thing basically. 2 negatives make a positive, so that's really 1 plus 7, which is 8. So we just need to answer the question, is 3 greater than or equal to 8? No. Okay. And so that would be a simple no. If this number does satisfy it, then we would obviously say yes. And so you'll have a couple of problems like that today at the beginning of your assignment where you just want to know. And the reason they do that and the reason we talk about that is because when we graph our inequalities today, there's going to be a lot of ordered pairs that work. It's not just going to be like one ordered pair that works where with like the 2 lines cross at like we can talk about. We're looking at any ordered pair that would make that inequality work. And so we're going to shade in our inequality, and we're going to use that for our graph. I'm going to pull up some graph paper today to do this on because I think it'll be a little bit neater, a little bit better probably to do it like this.
This whistler's gone. No.
Hey.
Yeah, you filled it out? No. Okay, you haven't. No, I did. I wrote my name. No, erase it. What? Erase it. Why? We're gonna make a copy. Miss Whistler isn't here. Since when is she not here? We're gonna make a copy of your copy and you can give it to Danica. I'll just like. I don't have an eraser. I erased it. Wait, why do you have a regular pencil? That's it.
I'll just ask the office if they have one. I don't know if this can put it out.
No, it's fine.
Okay.
Can't go, then I'll just go to which.
So we have slope-intercept form, which we have been working with. And when we graph slope-intercept form, we just have graphed the line and that's it.
No, you're not.
Okay? Today, the difference is instead of an equal sign, we have a less than or equal to sign. This is our M, this is our B, and we've talked about graphing the line, okay, but now we have a couple other things that we're going to add to it, okay? So first thing we're going to do is we're going to plot some points. Where do we start if we were to graph out a slope-intercept form? 3, okay, where at? On the y-axis. So make sure we go up 3, okay? That's our y-intercept. That's kind of like our starting point. From there, our slope is negative 2 over 5. And what we've talked about is that's our rise over run. We've done slope before. So we're going to go down 2, right 5. And we can do that as many times as we want. We can also go up 2 and left 5. So we can make a bunch of points. Do we need that many points? Not necessarily, but just to show you that you can keep going as many times as you want, just to get a little bit more accurate line. And so now we're going to connect this together. Well, before we make our line, there's 2 different lines that we can make, right? Solid line is what we typically do, but then today we sometimes we'll make a dashed line. If this is equal to, then it will be our normal solid line. If this was less than or greater than with no equal to underneath it, then it's going to be our dashed line or our dotted line. So in this case, we're going to connect all these points together with a line. Okay, and as long as we're in slope-intercept form, we can look at the inequality. Less than means below, right? And so what we're going to do is we're going to shade this line to everything below. Less than is underneath it, greater than would be above it. If you ever wanted to check, okay, and kind of like the problem that we did just a second ago, a point that would be really easy to check. I love 0, 0, because 0, 0 is a piece of cake. 2/5, negative 2/5 times 0 is 0. 0 plus 3 is 3. My y value is 0. Is 0 less than or equal to 3? That is a true statement, and it should work, right? And what's going to happen here is there's a ton of points I could use to check. Anything that's in this shaded region down here should make this inequality true. So there's a lot of things that make it true, right? An unlimited number of possibilities that would make that true. Anything that's up here in this region that's not shaded would not make that true. So that would be like a false statement, where if I picked an ordered pair right here and plugged it into the inequality, that would not make that inequality work, okay? So that's kind of what we're doing, okay? We're still graphing out a slope-intercept form a little bit. And then we have one like this. Okay, when we graph in this form, you really have 2 options here. You could solve it for y so it looks like the one we just did. I don't really want to solve for y here probably. I don't think that's the easiest, quickest method. There's nothing wrong with that. It would work, but there's some things you'd have to pay attention to, okay? So in this case, I still think the best way to graph this is to find the x-intercept and to find the y-intercept. Okay, so we want to find those two. Okay, thank you. Okay, so if I'm going to find the x-intercept, we plug in 0 for y. This is the cover-up method again. 2 times 0 is 0, right? So we're going to cover that up because it makes 0. So we have 4x equals 12. So to get x by itself, we just take 12 divided by 4, and that would give us x equals 3. Okay, and then we're going to do the y-intercept. So we're going to plug 0 in for x. 4 times 0 is 0, so we're going to cover it up. Negative 2y is equal to 12. You don't necessarily have to pay attention to the less than or equal to because we're just solving here. 12 divided by negative 2 would be a negative 6, and that would be our y-intercept. So on that one, we are not finding the slope. My sign is less than or equal to, so it's a solid line. And then we got to shade it. Okay, now here's what I will tell you. On standard form, you have to check. Okay, you can't guess because the sign won't always tell me which way it's going to be shaded. And so what I would do here is pick a point, any ordered pair you want. I love 0, 0. 0, 0 would be my go-to every single time if I could do it. The only time you really couldn't use it is if your line goes through 0, 0. But 0, 0 is so easy to plug in. 4 times 0 is 0. 2 times 0 is 0. 0 minus 0 is 0. Pretty easy, right? And so then I have 0 is less than or equal to 12. Is that true? Yeah. Okay. So 0, 0 is a good point. And so that means we want to shade on that side. And what I do is I usually just write a yes. Yes, it works. Okay. If I say no, then I'm going to shade over here. But if I say yes, then I'm going to shade that side. Okay. But you got to check it. Now, a lot of times people will look at this sign and they'll say, oh, less than or equal to. So less than or equal to typically means below, right? And notice that we are shading above here. The reason we're shading above is because we have a negative in front of the y. If I were to solve this equation for y, what would be my first step? Mm-hmm. So just to show you what this would look like, and we're trying to put it into slope-intercept form. Now I got to get rid of the negative 2, right? So I got to divide by negative 2, and when I do that, I'm going to do it all the way through. Now we've talked about this when we solved the single inequalities. Whenever I multiply or divide by a negative and I have an inequality, what do I have to do? You got to change the sign. Okay, so this would now become greater than or equal to, and then that would be 2x minus 6. Now, would it be okay to do this? Sure. And just notice that the similarities here, because it's going to go down 6, and then it would go up 2 over 1, up 2 over 1, up 2 over 1. It's the same graph, right? But I think rather than doing all that solving, the cover-up method is the easier way to go. But you have to check it, because now it's greater than, which means we're going to shade it. Okay? So you could do either one. Obviously, you don't have to do both, but I'm just showing you that those would be the two ways that we're going to graph, either at a slope-intercept or at a standard, depending on which method we have. Okay, what if I have x is greater than negative 3? If I have an x but no y in my inequality, what's that mean about my graph? What would my graph look like? Which axis is it going to cross? It's only going to cross the x, right? So if it only crosses the x, then what kind of line is it going to be if it never crosses the y? Undefined slope, right? It's a vertical line, straight up and down. Okay, so what we're going to do here is we're going to go left 3. Okay, now here's where you got to be careful. Do we have an equal sign underneath the less or the greater than symbol? Nope. So this is going to be a dashed line. And we're going to shade. Think about a number line. Greater than is always going to go right. Less than is always going to go left. So greater than means we're going to shade to the right of that line. Okay, so that's one of our special types of graphs because there's no y value in the inequality, then it's just going to be a vertical line. And then we shade it one way or the other. Okay, the other one would be one like this. This is our other type of graph that's a little bit different. Hey, this one has no x in it, right? So this one's only going to cross the y-axis, and it's only going to cross it at 2. So we're going to go up 2 on our y-axis. This is the one that has a slope of 0. It's a horizontal line. It's going to be a solid horizontal line. And then less than or equal to would be everything below. Greater than would be above, less than would be below. So that's how we kind of determine on those which way we're going to go. Okay, so we've done slope-intercept form, we've done standard form, we've done these two special ones with undefined and zero slope. The last thing that we're going to do here is a story problem with these. And if you have your book, you can get it out. If not, I'll just kind of walk you through this. This is on page 160. If you want to go grab your book real quick, you can, or you can just kind of follow along with me if you want. All right, so this is right in the middle of the page. It's just an example of a story problem. This company is manufacturing lawn chairs. And it says it takes 2 hours of labor to make a regular chair and 3 hours of labor for 2 hours of labor for a regular chair and 3 hours of labor for a lounge chair. A maximum of 84 hours of labor are available per day. And then it says X is the regular chairs. Y is the number of lounge chairs. Write an inequality describing the relationship between the number of each type of chair produced and the labor available. Okay, so because each regular chair takes 2 hours of labor, then we would say 2x. Each lounge chair takes 3 hours of labor. And 84 is the maximum number of hours that we have to spend, okay? Based on how much help I have and how, if they come into work, I'm gonna say, okay, we need this many lounge chairs made. So each lounge chair that they're gonna make is 3 hours or whatever. So it kind of depends on what you have in your inventory or how many you've sold or need to sell or whatever, okay? But 84 hours is the maximum hours of work we have available with the help that we have. Hey, now, another thing that should be included here, and it doesn't really ever say this, but because we're doing a story problem, we've talked about this a little bit before when we did some story problems earlier, is, in this case here, what can we not have? What does not make sense? What kind of numbers don't make sense here? Since we're talking about hours of labor. Negative, right? We can't have can't work negative number of hours. Okay, 500 wouldn't make sense either because it's bigger than 84. But yes, can I work a half an hour? Yeah. Okay. So fractions and decimals would still be okay, but negatives would not. And so what that tells me is that x must be greater than or equal to 0. Y must be greater than or equal to 0. So when I make my table in my graph here, all we're dealing with is the first quadrant, right? We don't need to worry about any quadrant that has any negatives in it at any point in time. We're only dealing with quadrant 1. Because our inequality is in standard form, then we're going to find the two intercepts here. We're going to find the x-intercept, and we're going to find the y-intercept. So if I plug 0 in for y, cover it up, 2x equals 84. 84 divided by 2 would be 42. I'm going to count by tens. And so 42 is going to be somewhere between 40 and 50. Okay, for my y-intercept, I'm going to plug 0 in for x. 2 times 0 is 0. So I have 3y equals 84. 84 divided by 3 gives me what? What'd you get, Zach? 28. Okay, and then it's less than or equal to, so we're just going to connect those two together with a line, and it's going to be a solid line because it's equal to. And then the last thing we have to do is shade it. So that's what a graph of the inequality is going to look like. Okay. Now, the last question asks, is it possible to produce 20 regular chairs and 20 lounge chairs in a day? Can I make 20 of each chair in a day? 20 times 2 is 40. 20 times 3 is 60. 40 plus 60 is 100, right? Is 100 less than or equal to 84?
No.
No. Okay. So it might ask you a question like that. It might ask you to name an ordered pair that does work. You don't have to use all the hours. So you don't have to use all 84 hours. So I could say like 10 of each, and it would be like down in here somewhere. Okay? Maybe we don't work all the hours that day. We just need to make a certain number of chairs and we'll be done for the day. Okay, so that's just an example of a story situation where you can graph the inequality with. All right. Assignment. Put that up here.